4 minimum pass sum from LeetCode. Given n by n grade field with non-negative numbers, find a path from top left to bottom right which minimizes the sum of all numbers along the path. You can only move either down or right. So let's see how this question can be done using this grid. In this example, the best way to get from here to here is going through the orange path, and we can only go to the right and we can go only to the bottom. Let's see if we can go any other path and if we can get a better result. Let's go from here to here. It's going to be 1 plus 1 is going to be 2, 2 plus 4 is going to be 6, 6 plus 2 is going to be 8, 8 plus 1 is going to be 9. 9 is bigger than 7. How about here? 1 plus 3 is going to be 4, 4 plus 5 is going to be 9, 9 plus 2 is going to be 11, 11 plus 1 is going to be 12, which is very bigger than 7. So now how can we solve this problem efficiently? For solving this problem, we are going to use dynamic programming, and we are going to define a grid the same size of the grid that we have, and we are going to fill out this grid from the bottom cell to the top, and we are going to get this field with the 4 conditions, and we are going to return the result at the end. So how we are going to fill this? We are going to find the minimum path. First thing, we are going to fill this cell, and then we are going to fill these cells, the bottom, the last row, and then the last column, and finally the rest of the grid. And what we are going to return is going to be this cell as a result. So let's see how we can do that. We are going to have 4 conditions. As I said, we are going to fill this, then this, then this, and then the rest. So we need 4 conditions. We are going to define a condition for the last cell. We are defining a condition for the last row. We are defining a condition for the last column and for the rest of the grid. So let's go through these 4 loops and see how we can do that. We are going to have 2 for loops for iterating over every single cell, but we are starting from the last cell. So which is going to be indexed 2 by 2. So it says like the first one, it says if the I is equal to 2 and j is not equal to 2. The second one says if j is equal to 2 but I is not equal to 2. And the third one, it says if I and j both are not equal to 2. And the last one says like no, if these conditions are not correct, you should put that value in that grid, which is going to, we are going to put 1 here, right? And so we are done with this if condition, which is just like this condition for filling this cell. Now we are going to fill out this row by using this if condition. This if condition is going to be valid because I is equal to 2 right now and j is equal to 1. So it says as long as I is equal to 2 and j is not equal to 2, we are going to fill these cells by the value that we have in here in the grid, right, which is 2, plus the value that we have in this cell. So 2 plus 1 is gonna be 3, and now I is 2 and j is 0. So what we are going to do, we are going to put this value plus 3 is gonna be 7 here. We are going to put 7 here. Now we are going to fill out this. So what we are going to do, we are going to I is going to be 1, and because we are done with the last cell, so what we are going to do, we are going to say the value that we have here plus the one that we have before. So it's gonna be 2, and then 1 plus 2 is gonna be 3. Now we start filling these cells. So what we are going to do, we are going to say the value that we have here plus the minimum of one of these values. As you see, we have the minimum of these values here. So 5 plus which one is the minimum, 2 or 3? 2 plus 2 is going to be 7, and then we are going to say 1 plus minimum of 7 and 7, it's 7, plus 7 plus 1 is going to be 8, and then we go for this one, 3. What is the minimum here? 7 or 3 is going to be 3. 3 plus 3 is going to be 6, and 1 is going to be plus the minimum of 6 and 8 is 6, is going to be 7, and that's the result. That's the result that we are going to return at the end from the DP grid. The time complexity for this solution is n by n, because we are going to iterate over every single value that we have in this grid, and the space complexity is n by n as well because of the dynamic programming grid that we are using. Thank you.